Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Tutorial, Part 11. Actually, today we will discuss about Pandas library. So in this video we will discuss Pandas series in details. As you can see here, all these 8 things from Pandas series we will discuss in this video. So let's get started without further delay. First of all, we need to install the Pandas library. Notice here, when we import the library, we didn't get any error. That means we have already installed the library. If this library don't have installed on your machine, then you can just type here this. And hit enter key, then starting the installation. So here we don't press the enter key, cause we already installed in our machine. Now we will know something about Pandas, it's necessary. Introduction to Pandas data structures. The heart of Pandas is just the 2 primary data structures on which all transactions, which are generally made during the analysis of data, are centralized. So one is the series, and another is data frame as you can see here. So in this part of the video, we will discuss about series. We will know about Pandas series. The series is the object of the Pandas library designed to represent one-dimensional data structures, similarly to an array but with some additional features. Its internal structure is simple and is composed of 2 arrays associated with each other. The main array has the purpose to hold the data of any NumPy type, to which each element is associated with a label, contained within the other array, called the index. As you can see inside the table, this is the index, and this the value. First we will declaring a series. To create a series, simply call the series constructor passing as an argument an array containing the values to be included in it. Let's see it. Let's execute it. As you can see from the output of the series, on the left there are the values in the index, which is a series of labels, and on the right the corresponding values. If you do not specify any index during the definition of the series, by default, Pandas will assign numerical values increasing from 0 as labels. In this case the labels correspond to the indexes, position in the array, of the elements within the series object. Often, however, it is preferable to create a series using meaningful labels in order to distinguish and identify each item regardless of the order in which they were inserted into the series. So now we will specify the index. So in this case it will be necessary, during the constructor call, to include the index option assigning an array of strings containing the labels. Now you can see here we got alphabetic index instead of numeric index. If you want to individually see the 2 arrays that make up this data structure, you can call the 2 attributes of the series as follows: Index and values. Now you can see here we got index and values individually. Now we will know about how to select internal elements. For that concerning individual elements, you can select them as an ordinary NumPy array, specifying the key. Let's see the example. Now you can see here we got -4 as index 1, as you can see. Or we can specify the label corresponding to the position of the index. As you can see here, we got same output, using label. In the same way we select multiple items in an NumPy array, we can specify the following. Now you can see here we got 2 elements from the series. Or even in this case, use the corresponding labels, but specifying the list of labels within an array. Again, you can see here we got same output using label. Now we will know how to assigning values to the elements. Now that we will understand how to select individual elements, and also know how to assign new values to them. In fact, we can select the value by index or label. Now you can see here, this is the original series, and this is the updated series. Now we will selecting by label. As you can see here, we got updated series by label. Now we will defining series from NumPy arrays and other series. You can define new series starting with NumPy arrays or existing series. So now here we import the NumPy library. Now you can see here, series from NumPy array. Now we will make a series from existing series. As you can see here. When doing this, however, you should always keep in mind that the values contained within the NumPy array or the original series are not copied, but are passed by reference. That is, the object is inserted dynamically within the new series object. If it changes, for example its internal element varies in value, then those changes will also be present in the new series object. Let's see an example. As you can see here, changes is present in the new series. Now we will know about filtering values. NumPy library as the base for the development of the pandas library, and as a result, for its data structures, many operations applicable to NumPy arrays are extended to the series. One of these is the filtering of the values contained within the data structure through conditions. Now you can see here, we got 9 and 12 which greater than 8. Now we will know about operations and mathematical functions. Other operations such as operators, or mathematical functions that are applicable to NumPy array can be extended to object series. Regarding the operators, you can simply write the arithmetic expression. Now here you can see the output. Now we will discuss about evaluating values. Often within a series there may be duplicate values, and then you may need to have information on what are the samples contained, counting duplicates, and whether a value is present or not in the series. In this regard, declare a series in which there are many duplicate values. Alright, as you can see here, we got 2 white and 2 green. To know all the values contained within the series excluding duplicates, we can use the unique function. The return value is an array containing the unique values in the series, though not necessarily in order. See here, we got 1023 as unique. A function similar to unique is the value counts function, which not only returns the unique values but calculates occurrences within a series. Now see here, calculated occurrences within series. Let's see here, 1 is 2 time, that's why we got 2. And rest of the elements calculated in similar way. So finally, is a function that evaluates the membership, that is, given a list of values, this function lets you know if these values are contained within the data structure. Boolean values that are returned can be very useful during the filtering of data within a series or in a column of a data frame. Let's see the example. Now see here, second method we got integer values. And first method we got Boolean values, as you can see. Now we will discuss about nan value. As we can see in the previous case, we tried to run the logarithm of a negative number and received nan as a result. This specific value nan, not a number, is used within pandas data structures to indicate the presence of an empty field or not definable numerically. Despite their problematic nature, however, pandas allows to explicitly define and add this value in a data structure, such as series. Within the array containing the values, we enter np.nan wherever we want to define a missing value. Let's see the example. As you can see the output, the is null, and not null, functions are very useful to identify the indexes without a value. As you can see here, actually this is the Boolean type, so here we got true, cause index 2 is nan. Now we will use notNull function. Now here we got false, cause the function is not null, but index 2 value is nan, so that's why we got false. In fact, these functions return two series with Boolean values that contains the true and false values depending on whether the item is a nan value or less. The isNull function returns true at nan values in the series. Inversely, the notNull function returns true if they are not nan. These functions are useful to be placed inside a filtering to make a condition. Now you can see here, we got all elements from series except index 2, because index 2 is nan. Now you see here we got exact opposite of the previous function. Now we will know about series as dictionaries. An alternative way to see a series is to think of them as an object dictionary. This similarity is also exploited during the definition of an object series. In fact, we can create a series from a dictionary previously defined. Let's see the example. Now you can see here we got series form dictionary. As we can see from this example, the array of index is filled with the values of the keys while the data with the corresponding values. We can also define the array indexes separately. In this case, control of correspondence between the keys of the dictionary and labels array of indexes will run. In case of mismatch, pandas will add value nan. Now you can see the output. Notice here, inside the dictionary we have 4 color like red, blue, yellow and orange, but there is no gray color. So in this case, pandas added value nan. Now we will discuss about operations between series. We have seen how to perform arithmetic operations between series and scalar values. The same thing is possible by performing operations between two series, but in this case even the labels come into play. In fact, one of the great potentials of this type of data structures is the ability of series to align data addressed differently between them by identifying their corresponding label. In the following example, you sum two series having only some elements in common with label. Let's see here, read from my dictionary plus my dictionary 1 equals 2400. And similarly yellow equals 1500. And rest of the elements are mismatched from both dictionary, so we got nan. So friends, today's pandas series tutorial was up to this. So thanks for watching the video, see you in the next video. Please subscribe our channel, and don't forget to like and share the video. Thank you.